assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, this is a pretty interesting problem, number 34, because we have a straight stream. I guess I'll draw a stream like this of protons that are passing a given point in space, which we'll say here. That's terrible. And we want to know the magnetic field that is produced over here 1.5 meters away from the beam. So the only thing they give us is the rate of protons, which is 2.5 times 10 to the 9 protons per second. So it doesn't seem right away that we can figure out what they want us to do. However, recall that protons are, of course, charged particles. And charged particles that are moving constitute a current. So then, we can define a current here as the rate times the charge of a proton. So say Q prot. And if you look at the units there, units of rate is proton per second, and Q prot is coulomb per proton. So it works out into being coulombs per second. Thus, we can calculate the magnetic field using equation 20-6 by saying the magnetic field from the stream is just equal to mu I all over 2 pi r. But as we just wrote here, you can write mu, I just wrote the same thing, mu times rate times Q prot, all divided by 2 pi r. And now we should check and see if we have everything. We have the rate that was given. The charge of a proton is pretty well known, and this is 4 pi times 10 to the minus 7. Luckily we have pi, and we have the distance r, which is 1.5 meters, that we want to measure the magnetic field at. So we can plug everything in and get that the magnetic field from the stream is 5.3 times 10 to the minus 17 Tesla. So an extremely, extremely small magnetic field. But if you calculate the current there, you'll see that the current is actually very, very small indeed. We're talking 10 to the minus 10 amps or so. So it makes sense that this is going to be a small magnetic field.